Hello, everyone. Good afternoon. Welcome to another Infogest Viva webinar. This is the 8th webinar of this series. My name is Daniela Freitas, and I would like to introduce you to Hernandez and Gaetan Drouin, who will conduct the webinar with me. This event is organized by a team of postdocs from Chagas Food Research Center in Ireland. The goal of these webinars is to share the latest findings in the field of digestion with presentations from the most recently graduated PhDs. This webinar is being recorded and will be available soon in the Infogest YouTube channel. The recorded presentation by today's speaker will be followed by a Q&A session with the speaker. So I'm inviting you to use the Q&A button at on your screen to ask your questions. Our speaker today is Dr. Jing Wang. Welcome, Jing. Jing did her PhD at the University of Copenhagen under the supervision of Dr. Lilia Arn. She is currently an associate professor at Northeast Agricultural University in China. And during her PhD, Jing worked on the effect of the characteristics of dairy products on calcium bioaccessibility. The title of her presentation today is Calcium Bioaccessibility in Dairy Snacks using the Cost Infogest protocol. So Jing, the floor is yours.
Good afternoon, everyone. My name is Jing Wang, and I received my PhD degree from the University of Copenhagen. My supervisor is Lilia Arn. Now I'm an associate professor working at Northeast Agricultural University in China. Many thanks for inviting me to share my research at the Infogest Viva webinar. And the title of my presentation is Dairy Snacks Designed with Improved Calcium Bioaccessibility. And the agenda is divided into background, main results of 4 studies, conclusions, and perspectives. And let's start with a background. Snacks are irreplaceable in our free time, and the snack food market was valued more than $400 billion in 2020. The snack food products are highly consumed in the developed countries due to the high commercialization and urbanization. And Asian Pacific represents the largest growing market for the snack food products because of the increasing demand from the developing countries such as India and China. And most popular snacks in the markets are chocolate, cookies, chips, and peanuts. In several national dietary guidelines, dairy products, nuts, fruits are recommended as healthy snacks. Moreover, there is a growing demand for on-the-go snacking with higher calcium content and lower fat and carbohydrates. And calcium is important for the bone health and teeth formation, and adults require at least 1 gram of calcium per day. And for adolescents, pregnant women, and the elderly, the calcium supplementary is especially recommended. And the main sources of calcium in our daily diet are from the dairy products, vegetables, cereals, and legumes. And calcium is most concentrated in dairy products. And more than 70% of calcium comes from the dairy products in the United States and Canada. And calcium in food is not the real nutritional value, and it needs to be released during digestion for further absorption. And there are 2 kinds of studies on calcium absorption: in vitro bioaccessibility, which is cheap, good control, high repeatable, and easy sampling, and the other one is the in vivo bioavailability. And I chose the in vitro digestion by cost Infogest method. It's a static model of human digestion simulated oral, gastric, and intestinal phases. And these are the simulated conditions and times. And calcium is the most abundant mineral in the dairy products. And the calcium equilibrium in milk is well studied. And in the aqueous phase, the calcium could exist as ionic calcium or bound to the citrate or hydrogen phosphate, and they are soluble. However, most of the calcium is in the micellar phase, which is bound to the phosphates in kissing micelles. So there are different types of calcium, and the total calcium in milk is all the calcium in the box, around 30 millimolar. And the soluble calcium is the calcium in the aqueous phase, and around 10 millimolar. And the ionic calcium is around 2 millimolar. Milk is an essential component of human diet, and dairy products resulting from milk, such as yogurt, provide essential nutrients for people, including proteins and calcium. However, most commercial dairy products require refrigerated or frozen storage. The formulation of dairy products has an impact on calcium absorption. Many studies have shown that milk proteins and peptides could bind calcium and protect the calcium from precipitating in small intestines. And the ionic salts such as phosphate will precipitate calcium and affect its absorption, while organic acid such as citric acid or malic acid will increase the calcium absorption. And some studies suggest that the lactose in milk may increase the calcium absorption. However, the polysaccharides are commonly used for dairy products as thickening agents, may reduce the calcium absorption. Among different food processing, drying is widely used for the production of snacks. So the main idea of this study is to produce the stable, attractive, and suitable texture of snacks to improve the calcium bioaccessibility. Then I will discuss the main results of 4 studies of my PhD research. The first study is about the effect of milk proteins, pectin, and heating prior to freeze-drying on texture and calcium bioaccessibility in snacks. And this study developed the yogurt snacks and established the method of calcium analysis, and it has been published in LWT. Here's the experimental method. The yogurt-based snacks were produced by freeze-drying and characterized the hardness and crispness by the texture analyzer. An in vitro digestion was carried out to determine the calcium bioaccessibility, including the ionic calcium by electrode and the soluble calcium by ICP-OES. And the yogurt bases were prepared using natural yogurt combined with different ratio of high methoxyl pectin, like no pectin, 30% of pectin, and 45% of pectin. And Y is yogurt and P is pectin. As well as the addition of whey protein isolates and caseins. And NH means no heating, and H means heating at 90 degrees for 10 minutes. And this is the results about the texture of the snacks. For the white bars, the samples without heating, we could find that the hardness increased and the crispness decreased with the increased ratio of pectin. The snacks without pectin of samples, yogurt 90% and pectin 0%, were very easy to break into pieces. So pectin is very important for the structural stability of snacks. And heating increased the hardness for the samples with higher protein content, such as yogurt 90% and the samples with the addition of whey protein isolates and caseins. And heating basically decreased the crispiness of the samples, except for the snacks with the caseins, which may be due to the calcium equilibrium of caseins. And this is the change of the ionic calcium during the in vitro digestion. The gastric phase was at pH 3 from 0 to 120 minutes, and the intestinal phase was at pH 7 from 120 minutes to 240 minutes. And we could find that the ionic calcium increased rapidly in 30 minutes of gastric phase because of the calcium released from caseins by pepsin at pH 3. And then it kept constant until the end of the gastric phase. And when the pH was adjusted to 7 of the intestinal digestion, the ionic calcium decreased by 70%. And it kept decreasing until the end of the intestinal digestion because of the precipitation. And the ionic calcium decreased with the decreasing yogurt ratio. And the casein addition increased the ionic calcium content because casein contains larger amount of calcium. Soluble calcium was measured at the beginning and at the end of intestinal digestion. There was a strong linear relationship between the soluble calcium and total calcium content, and the slope decreased from the 0.37 to 0.15 because of the precipitation of calcium during the intestinal digestion. And the biggest difference of soluble calcium were found in the samples with high casein content, and the smallest difference of soluble calcium was found in the samples with whey protein isolate, because the peptides or amino acid formed during the digestion of whey protein isolates prevent the calcium from precipitation in the intestines. And this will be further discussed in the fourth study. And the calcium bioaccessibility decreased from the beginning to the end of intestinal digestion because of the decrease of soluble calcium. And heating had no significant effect on calcium bioaccessibility. And at the end of digestion, the snacks with whey protein isolate had the highest calcium bioaccessibility. That may be because of the peptides or amino acid formed during the digestion of whey proteins. And the snacks with the caseins had a lower calcium bioaccessibility because casein contained large amount of calcium. And the increase in soluble calcium was lower than the increase in total calcium. And this is the summary of the first study. Calcium-rich snacks based on yogurt have been developed by freeze drying. Pectin provided snacks with suitable texture in terms of crispiness and hardness. And whey protein isolate addition provided the highest calcium bioaccessibility of 28%. And heating prior to freeze drying had little effect on the calcium bioaccessibility. And the second study is about improving calcium bioaccessibility by whey minerals solubilized by citric acid in combination with whey ingredients in snacks, which has been published in Foods. And the production of snacks and calcium analysis were similar with the first study, and the dissolution of whey minerals by lime juice was measured by ionic calcium and turbidity. The formulation of dairy bases included the natural yogurt, whey protein isolate, whey protein hydrolysis, whey mineral concentrate, and lime juice. And whey mineral concentrates contain 24% of calcium, meaning the calcium hydrogen phosphate. And in the sample name, Y is yogurt, I is whey protein isolate, H is whey protein hydrolysis, L is lime juice, C is whey mineral concentrate. And the pH of the lime juice was 2.28, and the lime juice addition decreased the pH of dairy bases. And this is the calcium analysis during digestion, and the green bars are the samples with lime juice, and the yellow bars are the samples without lime juice. And this is the total calcium. And in each bar, the left one, shorter one, is the ionic calcium, and the right one, higher one, is the soluble calcium. And the difference between the soluble calcium and ionic calcium is the complex bond calcium. And from the beginning to the end of digestion, total calcium was constant, and the ionic calcium and soluble calcium decreased. And the addition of whey minerals increased the total calcium, but had little effect on ionic calcium and soluble calcium. And the addition of lime juice increased the soluble calcium, but not the free calcium, which means the calcium complex bond to the carboxylate groups of the citric acid increased. Lime juice increased the calcium bioaccessibility significantly, and from the beginning to the end of intestinal digestion, the calcium bioaccessibility decreased except for the samples with whey protein isolates, which remained at 40%. And furthermore, the addition of whey protein increased the calcium bioaccessibility compared to the controlled samples, but the increase of whey protein's hydrolysis was lower than the samples with whey protein isolates, which may be because the hydrolysis contained calcium, and some of the hydrolyzed peptides in whey protein hydrolysis already bound to calcium. And this is how the calcium binds to the citrate. There are coordination bonds between the carboxylate groups of citrate and calcium, which are complex bonds in the intestines instead of the precipitation. And the calcium citrate keeps soluble at a neutral pH, and consequently increases the calcium bioaccessibility. In order to study the effect of citric acid on the dissolution of whey minerals, the aqueous solutions consisting whey mineral concentrate, whey protein isolate, and whey protein hydrolysis with or without lime juice were prepared. And the left side is at pH 3, and the right side is at pH 7. And we found that the samples with whey protein hydrolysis had higher free calcium, because hydrolysis had higher calcium content than whey protein isolates. And the presence of the citric acid lowered the free calcium concentration due to the complex bond. And calcium was solubilized at lower pH of the stomach, but precipitated at higher pH of intestine. For the turbidity, the protein aggregation and undissolved salts increased the turbidity, and at pH 3, the turbidity was low because of the dissolution of calcium phosphate. Lime juice is turbid. However, when the pH was adjusted to 7, the turbidity of solutions without lime juice increased a lot, but not for the samples with lime. This is further confirmed that whey minerals concentrates as calcium phosphate have lower solubility in the neutral condition, but can be solubilized by the addition of citric acid, leading to the supersaturation of calcium citrate. And this is the summary of the second study. The addition of whey mineral concentrates decreased the calcium bioaccessibility due to the presence of insoluble calcium phosphate, and the addition of citric acid increased the calcium solubility both from yogurt and whey minerals. And calcium complex bound to citric acid keep the calcium supersaturated and the neutral conditions, and consequently increase the calcium bioaccessibility. And the third study is about the effect of pectin degree of esterification on texture and calcium bioaccessibility in snacks, and has been published in Food Hydrocolloids. And pectin has a big influence on the viscosity of the yogurt bases, and therefore the rheological properties were measured, and the production of the yogurt snacks and calcium analysis were carried out as described previously. And in order to characterize the pectin and calcium interaction, the isothermal titration calorimeter was used to obtain the thermodynamic parameters. And 3 types of pectin with different degree of esterification were used for this study, including 2 high-methoxyl pectin of DE70 with random esterification and DE65 with blockwise esterification, and 1 LM pectin of DE38. Here is the formulation. And the yogurt bases content yogurt pectin with or without whey minerals and lime juice, and the addition of whey minerals and lime juice decreased the pH by around 0.2. And the apparent viscosity of yogurt bases decreased with the increasing shear rate, indicated the shear thinning behavior. And the yogurt bases with pectin of D38 and D65 had higher viscosity because these 2 pectins were calcium sensitive, and the interaction of calcium and pectin increased the viscosity. And the addition of whey minerals and lime juice decreased the viscosity of samples with LM pectin of D38. And the flow properties were quantified by fitting the parameters using the Herschel-Berkeley model, and the flow index N was lower than 1, which confirmed the shear thinning behavior of yogurt bases. And the samples of Y and YD17 showed almost no yield stress and very low consistency coefficient. And the samples of YD65 and YD38 exhibited the high values of yield stress and consistency coefficient, showing the interactions between the calcium and the pectins created a stronger gel network. And after freeze drying, the addition of pectin increased the hardness and crispness of snacks, and the controlled sample Y and YCl without pectin were very easy to break into pieces. And the snacks with LM pectin of D38 had the highest hardness and crispness because of the highest yield stress and consistency coefficient of yogurt bases. And this is the calcium analysis of yogurt snacks during the intestinal digestion. And the total calcium increased by around 1.5 milligram per gram of snacks with the addition of whey minerals. And the snacks with the DE38 had the lowest of the soluble calcium, free calcium, and complex bound calcium, which indicated that the DE38 could precipitate calcium during intestinal digestion. And the addition of Cl increased the complex bound calcium by around 2 to 3 times, which is in agreement with the results of the second study. And the calcium bioaccessibility at the end of digestion increased significantly with the addition of whey minerals and lime juice due to the complex bond of the carboxylate groups in citric acid. And the calcium bioaccessibility decreased with the decreasing degree of esterification of pectin, especially for the samples with LM pectin of DE38. And at the pH of 7 of the intestinal condition, the electrostatic interactions between the negatively charged of pectin and the positively charged of calcium are strong. And the pectin has a negative effect on calcium absorption because the bound calcium cannot be released and available during digestion. It's generally accepted that the dimerization between calcium and pectin chains follows the F-box model, and the pairs of the galacturonic acid chains are filled with the calcium ions. And this is the heat changes of titrating the pectin of the DE38 by calcium chloride, measured by isothermal titration calorimeter. And the negative values of peaks indicated the endothermic binding between the pectin and calcium. And increasing the temperature from 25 degrees to 37 degrees promoted the endothermic reaction and consequently increased the calcium binding to pectins. And increasing pH from the inherent pH of pectin to the pH 7 of the intestinal conditions also improved the calcium binding to pectins. Thermodynamic parameters were calculated by the integrating peak areas of thermograms. And the binding size N is molar calcium per molar galacturonic acid, and Ka is association constant, and delta G is Gilbert's free energy, delta H is enthalpy of binding, and delta S is entropy of binding. And LM pectin of DE38 had more binding size because LM pectin had more free carboxylate groups. And increasing pH from inherent pH to pH 7 increased the calcium binding size because the carboxylate groups are fully ionized at pH 7. And at 37 degrees and pH 7, the DE65 had higher binding affinity, probably due to the higher blockness. And at 25 degrees and inherent pH, the binding between calcium and DE65 was both enthalpy and entropy driving process, and for the other samples were controlled only by entropy. And this is the summary of the third study. LM pectin contributed a higher viscosity of yogurt bases and increased the hardness and crispness of freeze-dried snacks. And calcium binding to pectin increased with decreasing pectin degree of esterification, and accordingly decreased the calcium bioaccessibility. LM pectin reduced the calcium binding to citrate, decreasing the calcium bioaccessibility. HM pectin and whey minerals combined with lime juice created crispy snacks with high calcium bioaccessibility. The fourth study is about the effect of peptides formed during gastrointestinal digestion of whey proteins on calcium bioaccessibility, and it has been published in the Food Research International. This study used the model system with two major whey proteins of alpha-lactobumin and beta-lactoglobulin with the addition of calcium chloride, and during the intestinal digestion, ionic calcium, soluble calcium, and amino acid sequence were followed. And the samples with beta-lactoglobulin had a higher soluble calcium than the samples with alpha-lactobumin. And from the beginning to the end of the digestion, the blue bars compared to the green bars, the soluble calcium increased significantly for beta-lactoglobulin, but this increase was not significant for alpha-lactobumin, which probably due to the competition between the calcium binding to peptides and the calcium precipitation by the simulated digestive fluids. And the soluble calcium corresponds to the calcium bioaccessibility, and the samples with beta-lactoglobulin had higher calcium bioaccessibility than the samples with alpha-lactobumin. And the calcium bioaccessibility of the samples with 50 millimolar of calcium was lower than those with the 20 millimolar of calcium, because the increase in soluble calcium was lower than the increase in total calcium. And from the beginning to the end of the digestion, the ionic calcium decreased, but the complex bond calcium increased, because the peptides formed during digestion of proteins complex bond to calcium and competed with the precipitation at intestinal pH. And especially for the peptides from beta-lactoglobulin have more binding sites to bind calcium during digestion. And this is the peptides profile to indicate the peptide coverage during the digestion at different times. And there were 59 peptides identified in alpha-lactobumin and 491 peptides identified in beta-lactoglobulin. And the horizontal axis is the amino acid sequence, and the vertical axis is the different samples. The height of the bars means the count of the peptides, and the color means the total intensity of the peptides overlapping this region. And higher and darker bars were observed in beta-lactoglobulin, indicating more peptide count and intensity in agreement with the calcium results. For LC-MS analysis, only peptides with more than 4 amino acids could be detected. And from the beginning to the end of the intestinal digestion, the peptides detected decreased in all samples because the peptides were digested into undetectable oligopeptides or free amino acid. And a control experiment consisting calcium chloride with or without simulated digestion fluids was performed to study the effect of SDF on calcium absorption. And the SDF used for in vitro digestion contained the phosphate and carbonate as shown in the table, which could bind calcium as complexes or precipitates. We could find that the soluble calcium was higher in samples without SDF, indicating that SDF could precipitate calcium during digestion. And without SDF, the calcium bioaccessibility was more than 95%, indicating that the ultrafilters recovered almost all soluble calcium. With SDF, the calcium bioaccessibility decreased, especially for the samples with higher calcium chloride addition. And this is the summary of the study 4. Calcium complex binding to peptides formed during the gastrointestinal digestion of alpha-lactobumin and beta-lactoglobulin increased the calcium bioaccessibility with digestion time. And complex bound calcium correlated with counts of peptides formed during digestion, and the larger count and intensity of peptides formed from beta-lactoglobulin by the gastrointestinal enzymes. Phosphates and carbonates in the simulated digestion fluids decreased the calcium bioaccessibility. And here are the main conclusions. A balanced formulation with whey minerals, lime juice, and calcium-insensitive high methoxypectin yield crispy yogurt snacks with high calcium bioaccessibility, which provides a new perspective to design dairy products with high nutritional value. And citric acid enhanced the calcium solubility both from whey minerals and yogurt, and the citrate kept calcium supersaturated in the intestine. And decreasing degree of esterification and increasing blockness of pectin was found to increase the binding size and binding strength of calcium to pectin, resulting in a decrease in calcium bioaccessibility. And whey protein addition increased the calcium bioaccessibility with digestion time, mainly due to the complex binding of calcium to peptides formed by gastrointestinal enzymes, especially for beta-lactoglobulin, which prevented calcium precipitation in the intestines. And these are the perspectives. Some of the findings of calcium bioavailability can be validated using cockatoo cells or animal studies. And the role of food compounds, such as sugars and fat, on calcium binding and release can be investigated. And new snack processing techniques can be explored, such as extrusion or 3D printing. And the same methodologies can also be applied to other minerals, such as iron or zinc. And the calcium bioaccessibility can be studied in plant-based foods. And that's all for all my research study of my PhD, and thank you for listening. Good afternoon, everyone.
Thank you, very nice. Thank you very much, Jing, for your nice presentation. Can you turn your camera on? Okay, thank you.
Yes, thank you.
So now we can start with the Q&A section.
Yes. And I think we received one question.
Yep. So the question is, in your first study, what is bioaccessibility of calcium in freeze-dried yogurt-based snacks? It looks like calcium content of snacks differ markedly, correct? Do you think that influenced the results?
Yes. So actually, that the calcium content of snacks is different, and I can share the slides again, like here. Yeah, and I think that everyone could see my slides, right?
Okay.
Maybe I could close this one. And from these slides, you can see this axis is the total calcium content, and that all the samples, the total calcium content of all the samples is very different. And for the samples with high yogurt content, that the total calcium is very high, and also for the samples with caseins, that because of the casein content, very high amount of calcium. But when we calculate the calcium bioaccessibility, we could see these slides. Yeah, here is an equation for the calcium bioaccessibility. That is the percentage of soluble calcium divided by the total calcium. So actually, we already consider the total calcium content. So when we talk about the calcium bioaccessibility, we already consider the different total calcium content. So that's the reason for the result that here. Also for the first study, that's the reason why the samples with caseins had the lowest calcium bioaccessibility. That's because although that the sample had very high soluble calcium, but it also had very high total calcium content. So when the soluble calcium divided by the total calcium, the percentage was low. Yeah. So actually, that when we talk about the calcium bioaccessibility, we already consider the total calcium content. Yeah.
Okay, thank you very much.
Yes.
We will continue on the first study, Jing. You had an heating treatment. What's the effect of this heating in your study, according to you?
Yes. So for the first study, we think that heating both had effect on the texture properties and also the calcium digestion, because that the heating of yogurt formulations before freeze drying, we aimed to correct the pectin gels in the presence of the calcium ions from milk, and also to promote the formation between the milk proteins and the pectin, so that the heating could have both positive or negative effect on the texture and also the calcium digestion. Yes.
It makes sense. Thank you. Eva? No. So next question is, what are the main consumption groups of yogurt snacks?
Yes, it's a very good question, because we developed this yogurt snacks mainly fortified with the calcium. So it's very suitable for the people with calcium deficiency. And the freeze-dried yogurt contains the nutrients of yogurt, but it does not need to be stored at low temperatures. So this kind of snacks is very ideal for the people who go to school or work and can take the snacks with them. And also the texture of the snacks is very crispy and easy to chew. So we also think the snacks are very suitable for the elderly to eat. Yeah.
Thank you, Jing.
Do the snack has been based on snack in China mainly, on Europe, US?
Yeah, well, I think both. Yeah, because we develop, because for the calcium efficiency, it's very common in China. Yeah, and also like many Asian countries, because we don't drink that much milk or dairy products like the European or like the US. Yeah, so I think it's a very good product for us to try to improve our consumption for the dairy products. Yeah, and also for the European countries, I also think it's very important for the elderly to improve the calcium absorption. Yeah.
It is. I'm sure you surely have the question often, but would you mind to explain a brief mechanism or brief hypothesis that calcium bioaccessibility can be increased by increasing the soluble calcium?
Yes, so that's the main idea of that of my research, because the calcium is absorbed in the intestines by the vitamin D, and it dependent transcellular mechanism or by a pericellular mechanism. And both these two mechanisms are dependent on the soluble calcium present in the intestines. And most food calcium will dissolve under the acid condition of the stomach as the free calcium, like the ionic calcium. But with the risk of the precipitation during the intestinates because of the increasing pH from 3 to 7 of the intestinates. So the calcium binding to peptides or other complex binding could prevent such precipitation, including the hydroxy carboxylate complex binding. And more importantly, through the formation of the supersaturation, like my second study, like the supersaturation of the calcium and citric acid. So it could also help to improve the solubility in the intestine. So that could increase the calcium absorption. Yeah.
Thank you, Jing. I think that we have one more question.
Yes.
How is the complex bound calcium absorbed by the human body?
Yes, so in my study that we think the soluble calcium is the bioaccessible calcium that include the ionic calcium and complex bound calcium. So there is an equilibrium between the ionic calcium and complex bound calcium. And the complex bound calcium will dissociate when the ionic calcium is absorbed in the intestine through the two absorption mechanism, like I talked before, that the pericellular or transcellular transport. So when the ionic calcium decreased, the complex bound calcium will dissociate and turned into the ionic calcium and absorbed by human body. Yeah.
Thank you, Jing.
Yes.
So Jing will go for one last question before the end of the webinar. What is your further research plan?
Yes. So now I'm still doing the research that in China at the university. So I'm now planning to do the cell experiment, such as the Kakutu cell. That's also another method for the in vitro digestion. But that could be used to evaluate that what we call the calcium bioavailability is different with the bioaccessibility. It's more I think it's more accurate. And at the same time, I'm going to combine the two major animal source foods, it's milk and eggs, to optimize the processing of egg and milk foods, and to further study the absorption and utilization of the calcium and animal proteins. And so if there are any audience interested in this area, we can communicate by email. Yeah.
You will be able to find the email of Jing on the YouTube channel once we will have uploaded the video. So don't hesitate to contact her for any other questions.
Yes, welcome.
Ever, I think we can stop here because time is running out. So Jing, thank you really much for your brilliant presentation. It was really nice to hear that you're continuing as a topic and diving inside. I will ask you to stop to share your screen.
Yeah. Oh, yeah. Sorry. I forgot. Yeah.
Brilliant.
I stopped sharing. Yeah.
And like that, Ever will be able to share the slide for the next presenters. And the next presenters, so the next webinar will be the 7th of June, and we will welcome Isuri Jayawardana from the University of Sri Lanka. And she will discuss about kiwi fruit combat gluten intolerance. So we are waiting for all of you on the 7th of June. We had 20 participants today, a little less because the Zoom link changed last minute again. We'll try to improve on this. Anyways, the YouTube video will be available in a few days, so don't hesitate to watch it directly on the YouTube Infogest channel. In the meantime, I wish everyone a happy month of May, and thank you one more time, Jing. Bye-bye.